go ahead and say that we're live. All right, I'll give folks a few minutes. See who decides to pop in. If there's no one, I probably plan on making this recorded anyways, so that's fine. Oh, hi. You have someone in here. Nice to see you. nbagile. All right. So, since this is a recording, I'll just spiel. Basically, I'm developing a new library called nbagile, and it's basically nbdev, but designed for actual big companies. Where running raw nbdev, where we do everything in Jupyter notebooks and so on and so forth, everything that's hard or difficult about that is taken away. And so that means like having humongous Git differences because you're dealing with Jupyter notebooks. Having your testing actually follow, more PyTesty bits where you can do like actual coverage testing and you don't have to worry about converting notebooks into something that's compatible with PyTest. Documentation is just generated in anything that's compatible with Sphinx and Markdown. So all the tiny little frustrations that nbdev currently has, and I don't foresee changing, I'm going to go ahead and do. And the first step in this is documents and docstrings. So I'm, for my library, getting rid of the one-line docstring notion. Kind of. Basically, what my goal is, so if we look here at exporting docstrings, I want to take this function, this addition function, which looks like a FastAI or nbdev formatted function, right? And really nb verbose, because we have the documentation for each function defined, for each variable defined here, its return type, the one or multiple lined docstring, and then our function. And I want to pragmatically, hey Merv, how are you? I want to pragmatically convert this into this. That's the first step. That is the first baby step for nbagile. Is just to take something that's made in FastAI or nbdev and turn its syntax into something traditional software engineers are more used to. This sort of NumPy style documentation stream. And that turned into a rabbit hole. Basically, I'm going to retrace my steps for you guys so you understand how I got to the right answer and why I went to the right answer. Yes, learning FastAI and nbdev, all of the things. So the first thing we're doing here is I'm basically stealing nbdev code. This is actually coming from nbdev buildlib, which takes all the code, extracts it out, and converts it to a Python file. And the reason I did this is I want to sort of integrate this with nbdev. So all this really does is take a separate test notebook that I have open, which basically just has this in it, and grabs the actual source code for addition. And I wanted to basically just make sure that I could copy how this is done for testing. And so in my case, that means code should be defined as, if we just take a look at it here, minus the /ns, a string representation of a function, which is a lot of code to get there, but I wanted to make sure first that I understood how nbdev looked at every single thing that was being exported. So the next bit is to look at documents, because essentially what we need to do is extract all the variable information we can from this and then modify that docstring, right? Well, at first, for those of you that are familiar with my nvverbose library, if I do show doc and I do show doc code, I think this works. It doesn't. All right, I'm going to quickly define addition here, and you'll see why. I'm actually going to call it addition 1 so things don't break. You'll see that nbverbose is automatically able to get the types, the documentation, and everything associated with it, the return types, and so forth. There's an issue, though, with how that's done. I can't just simply take the code from show doc, figure out how it gets everything and formats it prettily, and just use it. Because this uses the inspect module. And technically, so does documents. So let me show you an example. So before, we had this, right? Document documents, which gets the document comments. It's a dictionary of the variable and the documentation string. But what you'll notice is the types are missing. But show doc just showed that we can do the types. So what happened? Let's take this code and run it again with full. Uh-oh, invalid syntax. And the reason for this one is I believe it needs to be external. So let's try this. Actually, I didn't need to do that. It just needed to be the actual function. You'll see here that we actually have the type annotations and the defaults and the return values and everything associated with it. So why can it do this? This is because it's using the inspect module internally. And inspect, to get these type annotations along with the document strings, can't use the source code. It needs the actual instance of the function for it to work. And that doesn't work for me because, I don't want that. I just want to use the source code. So documents is great. It can get me part of the way there. But that's it. I have to now figure out the best way for me to extract the types. And that's where things got a little bit tricky. My first version of this, which I spent a few days on, looks something like so. We pass in the source code, and you'll notice that I start messing around with locals and executing source code. And so basically what I did is, knowing that I can only have a live instance of the function definition, essentially, for me to use inspect, I, threw it into memory. Threw it into locals, which only has a scope of this function. So for those of you that don't know, you have globals, which is everything that is globally declared in your session. And you have locals, which is everything declared whatever scope you're currently in. So in like a function, this would be everything declared in this function. So if we look at the first, 3 lines, that would be source, annos, and original. And what I would do here is I would compare our original locals, our new locals, in case there were like multiple definitions or something, and then use inspect and get everything I needed possible. So that included the annotations, which is what those were, those type annotations, the documentation string, the param arguments, and the return annotation before finally cleaning up our memory. And this worked. I could get the annotation, and then from there, I wrote this function called Reformat Function, which is a little scary. But basically, we combine documents, that get annotations function we just made, and documents param locks, which gives me the line locations of every single parameter. Combine all of that together, and we can turn this source code, which, if taken out of context, is a documents defined function, and turn it into that pretty NumPy style documentation. Great. It works, right? No, it doesn't. Because this is hard-coded for specifically definitions. And even more than that, it's specifically for definitions in functions. If it's a class, it will break. And that's basically pseudo by design / scope. I just basically wanted something that worked. So then I wrote a tweet yesterday. And if I go and find it, where basically I asked if anyone kind of knew more or less a way to do this. Because I knew I could extract the documentation string. I can absolutely extract the documentation signature. But at this point, what I couldn't do without a lot of headache is the internals. I didn't want to do regex, because if I did regex, then, classes break and so on and so forth. And then Hamel Hussein, gave me a nibble. Ast Python. For those of you unfamiliar, Ast means abstract syntax trees. And it's a concept that's not just in Python, it's everywhere. It's in every programming language. And it's really the compiler code. So once Python, compiles everything, it's written in bytes that we don't necessarily understand. That is the abstract syntax tree, more or less. And so given this abstract syntax tree, or AST, we can figure out a whole bunch of information based on your lines of code. So for example, this AST tokens is an abstract syntax tree wrapper. So I wanted it to parse my source code, and it generates a whole bunch of nodes for me. And these nodes have a variety of information. So here I said, okay, if a node has a line number, so that's saying like, oh, I know what line this particular bit comes from, go ahead and print it out. And so this tells me, okay, we have our source code. Awesome. But then we have a whole bunch of extra stuff, because abstract syntax trees find everything. Thank you, Merv, for the sub. I still need to change those subs. So then I went, okay, well, that's great, but that's not quite what I want. Because really what I want is only return A plus B, and there's not a decent way to do that here. I could do @1, but as you add more and more functions, add classes and stuff, it's not consistent. I then found a library called Astonparse. Now, oh, thank you. There's essentially what Astonparse does is it takes some source code. Oh, you're all good. It takes some source code that we basically have, and after we've converted it to this Astonparse, where we told the Ast library to essentially convert this over into that abstract syntax tree format, it'll go ahead and parse it back. So, for example, I can do source and then say Astonparse source, and it gives me this weird Ast module where, like, you can see here, like, body contains a lot of my bits, and so 0 is the like function definition, and then I can say like args, and it gives me arguments, and it's like a whole bunch of things that you necessarily can't make sense of, and that's okay because it's machine code. But with Astonparse, I can say unparse, and there's my function. So it directly converted it back. And if we print this to see what it looks like, you'll see that it did a few things. It got rid of the documents and formatted our type signatures to where all of our variable definitions are on a single line. And the doc string is also on a single line, but it is always on the second line. Okay, my brain's starting to see this. Exactly. Now you know where I'm going with this. Black is going to be a part of this library and a part of this framework. Because we're going to get rid of the type hint. Or at least I might make it an option. I don't know. All this is based around the NumPy style documentation, and NumPy doesn't use type annotations, so I might get rid of them. We'll have to see. I could probably figure out a way to keep the type annotations, but also the doc string and still make it clean. That'd be interesting if I could. Because then it's super clean. But anyways, so we have this, right? Now the first step... okay, cool. Perfect. We'll just get rid of it entirely. Yeah, I think I remember a Twitter rant on duck typing at some point. I think about you? Yeah. All right, so let's see how we get rid of that. Digging through parse body, I could find that we had an args basically parameter or attribute. And what this does is, there we go, gives me a whole bunch of arguments, which, as you can probably imagine, are these arguments. And so it has a whole bunch of useful information for us in there. But I want to get rid of information. I specifically want to get rid of the type annotations. So not even, well, we've been going for 18 minutes, so probably 45 minutes ago, I went, okay, what happens if I just set that to none? Well, first I tried deleting it, and that broke. Then I was like, all right, well, if I set it to none, how does it unparse it? And we no longer have our type annotations. We do for the return, but that's okay. We didn't modify for the return. But that looks a lot cleaner, especially considering eventually we're going to, adjust this doc string. So then that got my mind thinking, okay, well, I need to make sure that this particular format always happens. Because essentially what I can do is take this and say, okay, the first line will always be the function definition, the second line will always be the doc string, and the third line down will always be the source code. I wanted to make sure that that was actually true. So we made a little test of a lot of variables. told it to Astonparse, rearrange the notation, and what do you know? It works. We have a super long function definition, but it's all on one line. So I can take this, reformat the docstring here, and recreate what I did here by getting rid of 99% of this code. That is the state of this project. So basically, the goals here, if we go back to here, now that we've had an introduction of where I am. So the first goal is, if we zoom in, when exporting source code, automatically have it use documents, change that docstring, and have it follow NumPy. Because then you can feed that to, like, say, black, and everything doesn't break. Export tests and throw them into PyTest. Documentation on Sphinx. And then the last challenge, which will be the very last stage, is individual notebooks can be dynamically generated for modules. So this is that aspect of using nbdev without using nbdev. You have the option of running in notebooks, but you don't need to. So a very direct use case for this is, let's say I want to make a PR to Hugging Face. And Hugging Face converted over to using nbagile. And let's say I had one particular file I wanted to either write a test for or improve the documentation. I pip install nbagile, have it recreate that one test, and everything is there directly like it would be for nbdev. Maybe with a little bit different syntax, export tags, and so forth that you're used to. But when you submit your PR, you don't submit the notebook. You run probably nbagile convert lib, or whatever the heck I decide to name it, and it then shoots everything back out. Documentation gets converted to a markdown, source code goes in the source code, tests go in the test and are converted to PyTest. And so you're no longer having to do like git diffs with a giant notebook of your edits. Everything is shot out into actual Python source code. Your notebook gets deleted, and then if they wanted to make an edit, okay, you take their suggestions, rebuild the notebook, and you move on with your way. So this way, if you want to stick with the notebooks, you absolutely can, but it keeps your code repository clean. Because your documentation from the notebooks is always there, so you can always see what you're thinking. The tests are properly stored in a safe location, and your source code is where it should be. And so that is the goal of nbagile. Take everything that nbdev can be and bring it there. So there's my pitch. Now let's have some fun. Basically what the rest of this stream is going to be is taking this, basically what we did just here with rearranging everything, and throw that back into this get annotations function. Now, yeah, Flake8 and Black and Hugging Fist prints. Yep, absolutely. Code formatters are in the real world. They're 100% used, and I don't want to ignore that at all. So that's kind of 99% of the reason why I'm doing this. Uh-oh, hang on. I have a notification somewhere of something. All right, cool. Nothing important. All that matters. All right, so what I want to do is take everything that we've done here. works. And bring it back up so I have further context. I'm going to clean the notebook eventually. Right now it's dirty, but that's just how development in NBDev kind of goes for me. So you don't actually really need get annotations at all. Because that gets the source code. I mean, I guess we do. We do need the annotations. The annotations are good to have. Now, to what extent we need them? Actually, we don't. Well, we don't if we keep track of them. So we could do something like this. And then have it like that. So that way, maybe we do. Hey, we don't. Astonparse is very helpful. Very, very helpful. Okay, so here's how we do this. If no. Oh no, my headphone died. Oh well. If no is not none, else oh. There we go. Now, if I check our annotations, then we can also even do dot strip new lines. There's our annotations. This gets rid of the need for this entire thing. This is what I meant by abstract syntax tree parsing is very, very cool. Because all of this having to generate like a local version and everything. I mean, we took this 30 lines of code, turned it to 7? 9? 9 lines of code? I'd say that's a win. I don't know about you. The last thing we need to figure out is the return annotations. And basically get rid of it. So first body returns dot annotation. That's annoying. Actually, wait. That's right. That's what we want, because then we just have it be unparsed. Oh my god, we're doing things. Things are happening. We can really only have one return annotation, so there's that. And then if we look at arg annos and return annos, oh, anno. We have everything. Okay, so now we take this get annotations function and instead have it just do this. Get rid of ret annos. Parse arg. I think that's pretty much everything. So then we just have it return arg annos ret anno. Okay, cool. Now let's make sure that this works when I don't have a return annotation. It did break. So then we want if parse.body 0.returns. I think this is what we want. It is. Hey! We're actually kind of getting there. This is cool. All right, so now we can get our annotations, which is a tuple of our types and the return annotation. And now we just need to throw that in here. So And actually, it's even more than that, isn't it? Well, this should be fine. Let's start a new reformat function. Okay, so we're going to say reformat function. Basically, copy this. And that's our properly formatted string. So everything else needs to be undone before then. All right, so we're going to say docs equals document source. That gets us our documentation string per input. Annotations equals get annotations source. We don't need the param locations because we already have that. And then we say filtered source equals, well, I guess it'd be unparsed source is that. And then how does this look currently? All right, so oh, that's what it was. .lstrip new line. All right, that's better. And that should give us what we need. Cool. So then we do how is this going to look? We can say function innards. How do you spell innards? It is. Equals unparsed source 2 and function definition is actually, we figured this out, didn't we? At some point. Yeah, it was this bit. So after we get the annotations, we do this, which then strips our source code of the type annotations. Function definition equals unparsed source at 0. And then what we do is the next stage here is I need to count the spacing of this. So I know how to format it right. Now I know there's a way I can do this with argparse, but I think we can do it like this. Count left spaces Python. Yeah, okay, I guess we can do that. Or we do that and be functional. What I missed? Oh. So this way, no matter if you use tabs or spaces, it will figure out what you want to use. And this way we'd have no special need to say, oh, are you going to use tabs or are you going to use spaces when you format your code? So I'm going to write get current, we'll get leading O. And we'll have it return that and O0. So we know what the white space was, and we know how many they were. So then we just say white space char equals get leading. And then we pass in unparsed source at 1. No, 2, because we need the line after the function definition. All right, so now we can write our function definition, which gets rid of all of this. And really, it's now we're writing the docstring. So can your function look like def a return 1? Oh, you mean this addition function? Or which function? All right, so we have our leading, like code parsing it to code that's analyzed looks like this. Yeah, absolutely it could. It is 100% not exactly the best style, but because we use AST parser, it will work. Now, this is 100% bad style, and I don't think any professional place would want you to do this. You would instead say something like returns 1. It would need to be documented in some form. You'd be flagged by their system, and that's kind of what we're aiming towards. Whether or not this breaks what we're doing, I don't think it does. But I'll write it down as something for us to test later. In case I forget, remind me, but the chat's right there, so I should be able to find it. Because it'd be really cool if it just works regardless of the code style, which is kind of what I'd like. All right, so back on track. We were rewriting function documentation. So basically, what we've done so far is taken this and turned it into this. That's all we have so far. Now we need the rest of it. So now I'm going to essentially, I think, just keep the same code here. Yeah, it needs to be in the function. You don't declare a doc string outside of the function. That's a Python thing. If you do something like because remember, Jupyter notebooks are disappearing. They're not going to be a thing. You need something to where I can do help A. And you can see that it currently tells me nothing. Now, technically, I can do a.doc equals my doc string, and then do help A, but that's not best practice. Really, you'd need that. For you to really technically call your code documented, it still wouldn't pass PEP 8, which is what all this is aimed to please. PEP 8 would have you do it like this. The triple quotes and your actual doc string should always be with the function itself and not defined outside. Great question. Exactly. Outputs PEP 8 standardized code from our NBDev-ish styled code that we've been working with. So basically bridge the gap between professional and unprofessional. So that way you look impressive without putting in the most effort possible and being efficient. All right, so white space characters. Let's write a NumPy style doc string. So we're going to say doc string equals blah for right now. And then we're going to say doc string plus equals, we give it a function. We're going to say white space char times num white space to get our formatted. It is a lot of time saved. And that's kind of the goal. Like, you're going to be super efficient when you're doing this without losing having your code be readable by actual software engineers or your managers or stuff who care about only the Python source code and not necessarily the Jupyter notebook that's going to take forever to render and read through. We're going to say parameters. And I'm trying to remember, somewhere I have an example. is NumPy. Okay, so we don't have trailing colons. All right, so then we're going to say new line. And then we're going to say for param, actually it's docstring plus equals f. Actually, it doesn't differentiate from black formatter. It's actually going to work with black formatter. What we're doing, yes, is we're taking Jeremy's branded document style of code and converting it into essentially things that from PyTorch or NumPy. Let me pull up one of my libraries to give you an example of what this looks like that I'm even talking about. So this is an open source library that I do for work called AdaptNLP. It's a Hugging Face wrapper. That's basically all you need to know. And that's not the best example. Let me try and find a better one. I think Model Hub might have it. So like this is an example of what one of my functions would look like. So you can see that like, well, I have a one-line documentation string here. I have each of my inputs on a new line, and there's a comment on the right of it that has what it actually is. This is very akin to something you would see out of like JavaScript. And so what documents does is, if you're using nbdev, extract these function documentation like this and renders it properly as documentation. So that's how, like in the beginning, I could get a very clean looking input format. Yes, exactly. And and when you're writing, it's a lot more streamlined because you're not having to remember, oh, this is what that param means, and you're having to rewrite username. Everything's just written once in a flow that you just don't break. And then as the user, you don't have to worry about converting your code back. It's just done. And you don't have to worry about it. It's an afterthought for you that you don't need to go and do. So that's the goal of this first part of the library. And I don't like doing that, so we're going to say we're going to just write this as a function. And then this should be, I counted this out, so it should be exact. Yep. Dash n. And then for param in param, what did I do here? We do use param locks. That's annoying. Let me go see what I just broke. Okay, so we do need this. That's fine. All right, so actually, wait, no, we don't. We got rid of the need for that. Because what we do is for param in let me think for a moment. I think it's return. equal. So if param does not equal return, which basically says we don't get the return annotation, then we do docstring plus equals f, our get whitespace function. Param, which is the parameter name, followed by annos at I is what this should be. So we need I and enumerate, because what this is getting is we're saying param name and the type. And then we're going to say new line, and then we're going to do get white space. How do we want to do this? This should be, this one we might actually write up by hand. Num white space plus 2, just so that way it's formatted. And actually, we'll do this. If white space char space. This one I will hard code because you can either have a space or a tab. Else, I'll say elif white space char equals tab. Yeah, that's annoying. All right. All right, we'll just have it do extra tabulated things, and I think black would format it to where it'd be fine. We'll check that later. I have a black playground, so we can play with it. All right, so then we need the actual white space char documentation. And this is going to be in docs. So we're going to say docs param. And then if annos -1 does not equal inspect empty. And basically this makes sure that we actually have a return annotation. Yeah, it's just. So current output's clear. Docstring plus equals f. Get white space returns new line. And then we do get white space followed by annos at -1 new line. I think this will render how I want. The big reveal will come in a moment. All right, so there's our doc string, and then we just need to combine it all together. So we're going to say new source equals blah. Function definition. That way we close off the parentheses. New source plus equals. Actually, we don't even need plus equals. We just say new source equals. Let me say unparsed. Actually, say function definition. I think this works. Function definition doc string function innards. Okay, hypothetically, this untested function works. There's our source. We broke something. What did I mess up? Oh. And return in docs.keys. Yeah, okay, so that won't work. Let's see if we can do something like this then. I'm pretty sure the correct answer is we do like string.join all three of them. But I think this should do just fine. We do need to do string.join, I think. Or format something a little better. Oh, that's what I messed up. Everything needs get leading white space. And this one doesn't need a new line. We'll make it have a new line. There's no harm in that. Oh, that's what we need to do. I knew there was a other for loop we needed. Actually, I guess we could just say dot join function innards. Oh, that's annoying. Do we ever use function innards again? No. Okay, so we can say that. Yeah, wait, almost. Hang on. I missed something. Hey! Oh, that looks so much cleaner. We took it from this mess to that. Oh, that's fantastic. I love that so much. Now, what I want to see though is, and I'm fairly certain this should not work. This shouldn't work on classes. Thanks for the follow. I'm like 99% sure that despite all of our efforts, this will still break. If it doesn't, I will actually do a dance around my room. That makes me feel a little better. Because actually it shouldn't. Reformatting a class will take a bit more effort. But what this should do, I think, is let us do something like this. Ah, that's annoying. Oh well, that's okay. That's actually okay, because with classes we do need to keep track of like how many spaces there are before it, right? Basically what we can do is just pass the function in and then prepend spaces across everything. So now let's spend a few minutes and clean everything. This is just an example of what, if I was smart, I would have just looked down here, but this is an example of like what we're going for. So this is a class in NumPy style docstring. With everything you need. So, time to get rid of a lot of code. Everything under here can go into flames. Then all we have to do is clean this up. I don't think I wanted to do that, but that's okay. Below we have an example string representation documents style. And then here, I'm going to write a test. Basically to make sure that we never accidentally break anything. Beautiful. Leading. should return a tuple of, what was this, 4 and space? 2 and space. And then reformat function. Should give me that. Now, for those of you that are familiar with test-driven development, you are probably yelling at me right now because I did not write my test first. That is because I had the test in my head, and we were kind of basically exploring the test as we were going. Just for initial development, because I had my set of goals. That's kind of how I code. It's a weird version of test-driven development that does exist. It's just not done often because you can break code a lot that way. And that's fine. I know I definitely need to work on my test-driven, but it's meant to be exploratory, so you write the test as you explore. Okay. That's cool. That is actually genuinely cool. I love that. All right, let me go ahead and do actual nbdev bits. I know you probably can't see this at all. I sadly don't know how to zoom in on this. nbdev clean notebooks, nbdev build lib, nbdev build docs. Now, eventually what I'm going to do is have this library build itself. So this doc strings, once we get it integrated with nbdev, we'll actually go through and modify it. And really, that's what this bit is. That's why this is important. I'm going to throw it in a cell. That way we have it. Because that is important. I know what that was from. Oh, that's annoying, but it's okay. This is literally the source code for nbdev build lib that I'm basically going through here. And so what we're going to do with this library is hack our own version of nbdev build lib that we call instead. That deals with everything. Cool. All right. I like that. Oh, let's go ahead and run everything again. Oh, this? Yeah, that's basically, I get that every once in a while. It's basically not allowing multiprocessing to go, which it's the Linux subsystem. I don't worry about it as much. I'm not running raw Linux, so it's okay if it can't generate multiple workers. Nope. I mean, it is nbdev. Basically, what nbdev was trying to do there was run nbdev build lib in multiple workers to make it faster. And multiprocessing was coming back and saying, you can't do multiprocessing. What do you think you're doing? It'll still run fine. It's just something to ignore. Cool. All right. I think I'm like mildly content with stopping there. At least for a minute. Because basically the next stage is getting classes working. And thank you. I'm not 100% sure what that's going to take yet. I mean, I kind of do, but I want my brain to rest for a while before we necessarily go and tackle it. So what I'll likely do is go take a walk, eat some dinner. Well, I already ate dinner. And probably go live again and try again in like maybe an hour or two. Check my Twitter and probably Twitch, and it'll tell you. But thanks for joining. There was a lot of people here, so I'm glad that you guys are excited with this tech. I know it definitely is going to have a lot of openings across everything, and really my goal with this isn't to make it non-flexible like nbdev is. The goal is every single little bit that I've done is optional. So you could have nbagile disable everything and nothing would happen. And so if you don't necessarily want the function documentation rewritten, you just disable it with a global flag. That's like closer to the end, but that's kind of what I'm thinking. So in any case, I'll see you guys probably in a few hours. Keep an eye on my Twitter if I decide to. If I don't, I'll probably try and stream tomorrow because I do kind of want to work on this every day. So, all right. Thank you so much, guys. Also, the other thing is if you decide to try and start using this just to play with things, this will, actually, not right now, but it will eventually. The GitHub CI will fail. Why it's currently failing, I'm curious about. Let's figure out why. When you decide to end the stream and then GitHub CI fails. Oh, that's why. That's easy. Settings INI 6. The other thing I'm making sure to do is this library is pinned on the specific version of fastcore that we're developing on. That's not going to change. And that way we have dependencies that always work and we don't have to worry about if a new version comes out. But anyways, all right. Bye, guys.